How's everybody? I'm Muthu. I'm CEO and co-founder of Ligero. I want to talk about what we've been building over the last year. I want to say that this is going to hopefully redefine the way we interact with zero-knowledge proofs. How many of you here have proved a zero-knowledge proof? Okay, quite a few. At the end of this talk, every one of you, if you have a cell phone, you can prove it straight from your cell phone. So if you are interested, please keep your phones out. Laptops are okay too, it'll run faster. So let's talk about, like today, what can we really prove in zero knowledge on a browser? This is just a scale of applications with increasing complexity. Think of it, the number represents the number of constraints that you need to verify. I'll say that most people have reached probably the 1 million benchmark. And in fact, when you talk to teams that have deployed this on the browser, they don't want to go beyond 1 million because either your key size is too huge, like for Groth 16, or you just take too much time to do it on the client's device. So, as is customary usually in these talks, there is an apt Vitalik tweet to talk about. So, late last year, Vitalik says that, ironically, privacy use cases haven't reached client-side proving. And this is because client-side proving hasn't been able to do anything beyond Merkle trees. We want to challenge this status quo. So let me quickly, let me say this. I think we would be able to do real-time Ethereum block proving from the browser. I'd say even in a year time. This is my prediction. So let me quickly tell you, take the Ligero zero-knowledge proof system for a test drive. So this is a simple speed test that we created. I will share the link later. You can all try it on your device, how fast it goes. So this speed basically says that we can do 4 million constraints per second on this laptop. Granted, my laptop is an M4 that I bought yesterday just to, show how well our system scales. But even on an M1, this is going to be pretty fast. So if you have any laptops, don't trust me, verify. Go check. I'll share you the link. You can actually test how fast the Ligero system will perform on your device. Okay, that's about predictions. Now, maybe just to give you a little context of what you just saw in the speed test. On the speed test, we were just running a program that would prove Poseidon hashes on the browser. And this is a slide that the part of the table I borrowed from Eli Ben-Sasson's talk last year, where he was talking about the Stone and the Stew provers. The Stone prover, back when it was started, they were able to prove 500 hashes per second on like a quad core Intel i7 machine. And then they switched, of course, they made amazing improvements and switched to a small prime, and they were able to go to 500,000. Now I want to say back in the original sort of 254-bit or even 250-bit regime, on the browser, we can do about 27,000 Poseidons per second. And we haven't yet optimized stuff. This is just like sort of preliminary numbers that you can do from the browser. And just to give you a sense, you want like 500,000 or roughly or on that order to prove an Ethereum block. But our vision, I want to say, is something different. Yes, we have built zero knowledge that can be scalable, that can run fast on the browser. But really, our motivation comes from building useful and usable privacy tools. And this is what I want to talk to you about. So today, privacy comes with a lot of trade-offs. And just thinking about the applications that zero knowledge can enable today, enterprise that want to use ZK, they have to make a trade-off. Either they get privacy without compliance or compliance without privacy. Privacy comes at a cost. You want to employ prover networks, you got to pay. And you shouldn't share your data to a prover network. So, privacy also comes at the cost of usability. The ones that are trying to bring privacy tools require you to learn new tool chains. And this reduces the amount of development that's going to happen in the system. And finally, again, often you have to trade off your privacy with trusting someone with your sensitive information. What we want to do is we want to build useful privacy. And in our mind, what useful privacy is applications that people would really want private. And I want to say there are a lot of people and an amazing set of people, especially even in the Ethereum community, that is trying to push this privacy applications, from ZK email, ZK TLS, as well as keyless login by Aptos and Miston Labs. And also on the enterprise side, there are so many applications where they don't want to reveal investor credentials. The Europe is moving to digital ID. There are numerous applications that want zero knowledge today. And these I classify as privacy applications for individuals because you want to run them client side. Now, privacy also matters for organizations. And for us, this is captured by ZK Validiums. You can think of enterprises and organizations opening their own chains, and they can control the privacy of their chains. And they can hook onto Ethereum, any of these blockchains, as a Validium. Usable, in our mind, is that you want the ZK to be usable. Yes, there is a lot of, I want to say, amazing work done in zero knowledge. I want to say I'm a professor at Georgetown University. I've been teaching zero knowledge now for close to a decade, and the progress that we have seen in zero knowledge is incredible, right? But still, to get to the point of being usable, we want standard tool chains, and today this is evolving this way. People are developing more and more ZK VMs, affordable hardware. I mean, if you want client-side proving, you shouldn't have to go and buy an NVIDIA 4090. It would be great if you could just run it from the device you already have in your hand or in your bag. Portable implementation. If developers want to build zero knowledge, they want to deploy it. People would want to run these things on their phones, on their devices. You cannot ask them buy an NVIDIA GPU or buy a specific laptop. And finally, you want a privacy default approach. And again, this is a lot of the ZK today is focused on applications that don't demand privacy. So they are not sort of focusing and also refining their systems. All systems can be made zero knowledge. It's just that it's not default today. So I kind of covered this, that the modern ZK kind of falls short. And here are just some of the reasons, just technical reasons. ZK snarks, often some of them need huge memory. Start-based ZK, again, they cannot run client-side yet. Like if you want to use recursive composition shards, this is not going to scale on the client side. And most ZKs are built for verifiability, and the privacy ones require their own tool chains. You have to learn NOAR, or you will have to learn CIRCOM. And in fact, this is what people are doing today. There's so much of application built in CIRCOM and NOAR for these privacy applications. So today in ETH Denver, we want to unveil our zero knowledge platform that's going to redefine the way you are going to build zero knowledge applications. So let me quickly run through a demo on how we can do this. So here is our platform, and I'll share the link at the end of the talk. Anyone can go here. There are already a few zero knowledge applications on the marketplace. For people who don't want to develop them, you can already go and run them. I'm going to just pick one of them. This is something about text redaction. I want to prove that I'm a whistleblower. I have some email. I just want to reveal some of these contents and prove that I have the original message. You can go here. You can change the inputs over here to whatever you want and hit prove. And it's going to run straight from your device. So this, once you build it in our platform, you can deploy it directly, and anyone just with a browser, even on a mobile phone, can change inputs and can start using your application. And let me quickly walk you through how easy it will be to even build these applications. So not the text redaction. Let me go back. So here is a simple application that measures edit distance between strings that's useful for genomic research. I've written this code in C++. All you will have to do in our system is write this and compile. And once you compile, you can run. That's it. So you can do an entire application from the browser. You can write your application in C, C++, And this week, we have also integrated Rust. So you can also put Rust programs in our system, compile it, and you can deploy it. And once you hit deploy, it will go to the marketplace, and anyone with just a cell phone browser can run your zero-knowledge application. Imagine that. So let me get back. Here is a quick benchmark. Please take the benchmarks with a grain of salt. We've tried our best to be apples to apples, but this never happens in the ZK land. So we tried the NovaNet, and thanks, Wyatt, for helping us with your system. Sorry if the performance doesn't really match what you have. We try to do it on our system, but I'm sure major improvements are coming in these systems. So NovaNet is slightly under a kilohertz. We tried Noah's system that's around like 44 kilohertz. The one you just saw like on my laptop is the fourth one, which is about half a megahertz. I want to say that if you want to run like more, there's a difference between running structured application and unstructured. Structured is about, hey, I want to verify many things, many signatures at the same time. And unstructured is like edit distance. And there is a difference in performance. And I want to say that when you want to think of real-time Ethereum block proving, it's about like tons and tons of hashes, tons and tons of signature verification. You can look at the last line. We can go beyond 1 megahertz. And if you have a better laptop, you can go up to 6 megahertz. And I want to say these are preliminary numbers. We have focused on a 252-bit prime because we want usable applications. Usable applications today need signature verifications on big primes. But if we reduce into a small prime, which we can, just like Starks do, then we are going to get a 20x improvement straight from here. So let me tell you 2 slides. These are the only technical slides I'm going to tell you, and if you want to zone out, please do, and I'll get back after that. So the zero knowledge behind our system is called Ligetron, which is based on the Ligero proof system that was published back in 2017. Ligetron is Ligero but memory efficient. It is also a ZK VM. This is what allows you to code in C, C++, and Rust, and ZK by default. And finally, we used web GPUs. I know that web GPU is still maturing, but we've managed to get a lot of coverage with a lot of devices, and this is only going to improve because AI needs GPUs. So web GPU is definitely going to mature, and we focused on doing it on web GPU as opposed to CUDA because we wanted portability. We want everyone to be able to run zero knowledge. What is the secret ingredient? Well, there isn't any secret ingredient, and that picture is really for my 4-year-old daughter who's watching Kung Fu Panda every day. But our system is hash-based, just like ZK Starks. But the main difference is we use a different way to do constraints, and we do code interleaving. And if you don't know what code interleaving, it's fine. If you have heard of breakdown, breakdown uses Ligero's commitment scheme, which is code interleaving. And that allows you like a lot of parallelism. You don't need too much memory, and this is what we can leverage. And finally, I can tell you about memory efficiency, but if you know a little bit about the Ligero system, it's based on something called MPC in the head. If your underlying MPC is memory efficient, we can borrow that straight into the Ligero system. But don't discount that. I mean, a lot of effort has gone into engineering this reality. My engineer keeps telling me that, hey, like you can tell theoretically a lot of stuff, but until you get to deploy it, it's not real. So even though I can argue theoretically why it's memory efficient, still a lot of engineering efforts gone to making that. A little bit about just the last couple of slides. Here is our roadmap. Today we can integrate C, C++, Rust. I want to say pretty soon you're going to get CIRCOM. And once you get CIRCOM, all the amazing work ident3 has done and everyone has done, you can just copy paste that CIRCOM code onto our browser, and now voila, you can do all of those applications from ZK email to ZK login, etc. I'll also say that what we are focusing beyond this is a plug-and-play solution for identity. We want a no-code version of our, we shouldn't have to code. Once I have a suite of ways of proving my identity, it should just be checkboxes and I should be able to deploy an identity tool on my Web3 or even Web2. And we are also looking into ZK Validiums. We think truly this is a way for organizations to get scalability and privacy. And also our ZK VM, I've not talked about it, but we are going to get sort of off-chain compute, of databases, AI, etc., we can equip ZK rollups and validiums with this additional features that people will want. And that's in phase 1, but in phase 2, we also want to incorporate NOR and Cairo, because a lot of work is that we don't want these efforts to be duplicated on our system. If you can just borrow these and cross-link, then you can code in C, pick a function from Cairo and pick another function from Circom and be able to compile it down. And I want to say just a small thing here. WebAssembly helps as the intermediate representation because it has this module concept. In RISC-V, this is going to get a little more tricky to do it. So we chose WebAssembly, I mean, for other reasons, but this benefit is something that we are going to get from that. And finally, back to my prediction, I think we'd be able to, I predict that we'll be able to do real-time block proving and even LLM inference from the browser. If you want to test how fast your device can prove, just scan the QR code. If you have a laptop, you can just go to this site, dev-platform.ligetron.com/speedtest. So if you like it, please share it. Tell us what numbers you got. That's our Twitter handle. ZK, anywhere, everywhere. Thank you.